All right, so to pick up where we left off, we were over in the matches table, assigning data types to each of the fields. So the team IDs for this table are both going to be integers. Match ID in the games table is also going to be an integer, along with game number and winning team ID. In the bowler scores table, match ID is going to be an integer. Game number will also be an integer. And then bowler ID will also be an integer. Raw score and handicap score are both going to be integers because we're storing whole number scores. I don't think we have decimal scores in bowling. And the one game, there's no Boolean data type in SQL Server, so we are going to store it as a 0 or a 1, which we can use as an integer or a varchar. In this case, I'm going to store it as an integer. Alright, so that about wraps up all the data types. Now I want to show you how to create the relationships between each of these tables. So let's go ahead and start with the bowlers and teams tables. If we recall what Bob said, he said that a bowler needs to be on a team and a team can't exist without having any players on it. So if we talk through this logic out loud, we can say that logically a bowler has to be on a team and they can only be on one team. And a team can have many bowlers on it, and it has to have bowlers on it for it to exist. Yeah, if we just review what Bob said, it needs to be on a team can't exist without having any players on it. So we're going to come down here with the team ID and link that to that foreign key. And that's saying a team, read down the line, can have many players, and a bowler, read down the line, can only be on one team. That method helps me better understand ERDs and how to read the relationships that are documented with these arrows between each of these tables. Now, I want to go a little bit more in depth with this relationship right here. So if you remember, Bob said that a team absolutely cannot exist without having any bowlers on it. So it's more than just a team has to have many bowlers. The team has to at least have one. So that's where these dual endpoint heads come in. So if you go over here, you click on the endpoint drop down, and we can change it to a one many endpoint. So what that is saying, if we read down the line, then we've got the team can have many bowlers on it, but it needs to have at least one. That's what this one is representing on this endpoint. We can do the same for bowlers. So like Bob said, a bowler has to be on a team and they can only be on one team. So that means that there's going to be no null instances of team ID in the bowlers table. So we can change this endpoint to be a 1-1. Again, reiterating that a bowler can only be on one team and they have to be on a team in the database. All right, and then we've got a captain ID that's going to link over to the bowlers table. Like Bob said, a captain has to be a registered bowler with us, and a bowler can only be the captain of one team. So this is going to be a 1-1 relationship. So we're going to go ahead and change those endpoints. And we can also get a little bit more in depth with this one too. So a bowler can be a captain of a team, but not all bowlers are going to be captains of a team. So if we read down this line, a bowler doesn't necessarily have to be a captain, so that's going to be the 0. Sorry, wrong side. But they can only be up to one captain of a team. And if we read the other way, we're saying a captain has to be a bowler and they have to exist in the database with this 1-1. So this is saying a team has to have at least one captain and it can only have one captain. So that's what that 1-1 is saying. All right, if we move on to the matches table, we've got a foreign key to tournament ID. So like Bob said, a tournament has many matches. And he's saying a tournament has to have at least one match. So this is really important. So I know off the bat that this is a one-to-many. And the fact that Bob said a tournament has to have at least one match, that's telling me that this endpoint has to be the one-many. Because if you read down the line, like we've done before, the tournament has to have at least one match and can have up to many matches for the tournament. And if we read the other way, the matches are going to be associated with one tournament and one tournament only. Because as you can see, it's going to be a unique ID for this match. So that means that this endpoint is going to be the 1-1. All right, so we've got some team IDs here in the matches table, so we're going to link those. So a team can play many matches, but a match can only have one team in this odd lane and even lane team slots. So we're going to go ahead and draw that relationship. Sorry, that's backwards. The team can play many matches for either of these slots. Let's move this. All right. So you might have some teams that choose not to play in tournaments or any matches, or simply just haven't had the chance to. So what that tells us is that this relationship needs to be a 0-to-many, or excuse me, a 0-many endpoint for both of these. So to reiterate what this is saying, a team can participate in 0 matches if they don't want to, just haven't had the chance to, and they can participate in up to many or infinity matches. And then if we read the other way, so each match has to have a team in each of these slots. There cannot be a null instance because a team can't play itself for a match. So this means that both of these lines are going to have 1-1 endpoints next to the teams table. So again, what this is saying is a team, let's separate these out. This is saying that a team can be associated with one team ID over here and one team ID only. All right, so let's go ahead and move on to the games table, which is going to link to our matches table. So a match is going to have many games, if you recalled what Bob said. So it's going to be a 1-to-many with connecting with the composite primary key, which also kind of acts as a foreign key in this case. So a match has to have games to be a match, or else it wouldn't really make sense. So that means that this endpoint by the games table is going to be a 1-many, again meaning that a match can have one game and up to many games. Typically, a match, like Bob said, will have 3 games, but for the sake of this database, we're going to plan it out as it can have one game if it wants to. All right, and then this game number is going to connect. Actually, before we do that, let's do this winning team ID. So a team can win many games, but a single game instance can only be associated with one winning team because you can't have 2 teams winning. For the scope of this ERD, we're not going to account for ties, so we're just going to focus on winning teams. So again, a team doesn't necessarily have to win any games because they can be a really bad team, so that's going to be a 0-many endpoint, saying that a team can win 0 games and up to many games. And then the other side of this endpoint is going to be a 1-1 because a winning team has to be associated with a single team in the teams table and only one team in the teams table. Sorry, it's like really cluttered right there. Let's see if I can clear that up a bit. All right, so hopefully you can see that better. Now we're going to go ahead and move on to game number from games linking to bowler scores. Now this is going to be a one-to-many because a single match and a single game instance is associated with a single team which has many bowlers on it. So a single match game is going to be associated with many different bowlers' scores. So Sally, May, and Bob can all play on the same team but all have different scores for that match and game number. So that's why it's a one-to-many. And that's going to be the same for match ID because it's the composite primary key, just going over there. And then bowler ID right here is going to link to our bowler ID in the bowlers table. So a bowler can have many instances of scores, so that's going to be a one-to-many. However, a bowler doesn't necessarily have to have any recorded scores, so that's going to be the the zero-many endpoint. And a bowler score is going to be directly connected to one bowler and one bowler only. So that's going to be the 1-1 endpoint again. All right, so that about wraps it up for the relationship building part of the ERD. If we come over here to this export button, we can select what SQL Server we want to export our schema to. So what this will create, it will create a database schema that you can run in your database to create the tables. Now what you want to do before you run this, you need to say create database. So I'll just input it here so you can see what I'm doing. And you want to create this before you even start making your tables, or else it's going to break. I even sometimes run this as a separate query because sometimes SQL Server can be a little bit finicky with this. So yeah, this will create all your tables. It implements primary keys and foreign keys. And if we scroll down, we can see that it is making composite primary keys. Sorry, I'm in my school right now. I'll switch to SQL Server so you can better understand this. So yeah, it's creating an index composite primary key on bowler scores, match ID, game number, and bowler ID. So this will create all the relationships between your tables really easily. And once you run this, you'll be ready to put in any kind of data that you want to in your database. So thanks for watching. If you have any more questions about ERDs, don't hesitate to use Google, and W3 Schools is a good source. Stack Overflow is really good. So yeah, once you learn how to do ERDs, databasing is a breeze, and hope you join me on the next video.